film number 5 in this series of films on AD and DA converters, and now we move into the AD converters and go through different kinds of converters which have different properties. There are 5 different converters: flash, ramp, successive approximation, sigma delta, and pipelined. And this first film of those will cover the flash converters. The flash converter is based on an op-amp again, and this op-amp is without the feedback, and so this means that it is like the one we watched in last week when we had the instrumentation amplifier with a short circuit instead of RG. So this will basically only be able to tell which one is the larger. Is that one the largest, or is that one the largest? One of the two. So those op-amps here only can only tell if V plus is larger than V minus. If this condition is true, that will lead to a high. If that condition is false, that would lead to a low. So it's a very basic 1-bit converter. Each of those is a 1-bit converter. Now, what I have here is I have a reference voltage coming in here, and that is sent into a series of resistors down here that will actually divide the Vref into, in this case, 1, 2, 3, 4, 5, 6, 7, 8 levels. So you divide it into 8 levels, which will create 3 bits, because 2 to the power of 3 equals 8. So 8 levels, and then we have the V in here connected to each and every op-amp in the converter, and each and every one of them checks the same condition: is the voltage at the plus terminal larger than the voltage at the minus terminal? Remember that the voltage at the minus terminal here starts off as Vref, then it gets lower, 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 and all the way down to the one step above 0 volts. So each and every one of those checks if Vref is higher than the voltage on the minus terminal. And let's say, for example, that Vref here is 8 volts. That would create the stepwise here: 7, 6, 5, 4, 3, 2, 1, and 0. Let's say that the V in is 2.8 volts. 2.8 is not larger than 8, so that will create a false or a low on this one. 2.8 not larger than 7, low. 2.8 and 6, 2.85, 2.8 and 4, 2.8 and 3, 2.8 and 2. This will create a high and a high. If I increase the voltage here to 6.8, then I get high, 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 high. So the amount of op-amps that gives a high as an output is defined by the input voltage. So this little piece of digital circuit here will convert those 8 lines into a 3-line binary output. It's actually a very simple circuit, but I will not go through the theory here. The disadvantage here is that a large resolution gives an enormous amount of op-amps, because you need the number of op-amps that which is the number of steps. So for example, for a 16-bit conversion. That will be 2 to the 16 levels. 64,000 levels, which is 64,000 op-amps. Far too many. So it's quite impossible to use this for more levels than actually like this. A 3-bit, maybe a 4-bit converter, then you can use flash. The advantage, on the other hand, comes with name, flash. It's very fast converter. It converts on the fly. So there is no converter that is faster than the flash converter. But then again, you cannot use it when you have a resolution much over 4 bits, because that would create an enormous or require an enormous amount of op-amps.